Hello, 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 and welcome to another One Lion of Code. I am One Lion, and we will be doing some code on stream. Here we go. Done. Everything is done. We don't need to do anything else. Good stream. Thanks, everyone. Hope you join me. I'm kidding. Hi. Hello. Hope you're all doing well. I am having a fun day so far. I've been able to keep my head down and do some work. Wow. I'm no longer able to hear. But that's fine as long as you guys can still hear me. Oh, turning my headphones down just a smidge. I got this. What happened? Hello, Apocalypse. APOC. Oh. The world ended. Hey, Poc. Says Thindle. And hello, Thindle. Hello, Duke of Soft. You indeed were first. Again, hope you're having a great start to your week. For those of you that have a holiday today in the US, Martin Luther King Day, I hope you're able to enjoy it. I am working today because Sajetti doesn't observe that holiday and my client does, but we're still billing and it's a mess. It's a big mess. So anyway, not now, I guess. Whew, I have a day. Yeah, so Martin Luther King Jr. Day today in the US. Most places observe it. So we've been playing with the bot, having lots of fun. We've been adding this archery game, and it does seem to work. And now I have added elevation to the target. So if I try shoot, and I try something like maybe 5 at 80, ah, went right through it. Are you telling me that I went over or flew quite high and far away from the target? And that should have went under. Does that count as going under? A bit high still. Yeah, so I don't know. Oh no, you ruined my script. Anyway, Thindle asks, Zelda had got a new friend named Poor Kitty. What? Anyway, do you want to see what I got? Was it the emote? The animated version of Zelda, it looks like. Also Zelda. Hello, Disco. So what script did I ruin, APOC? Was it for the archery? Because right now the elevation is not working. The first one is well drawn, second one is poorly drawn. Ah, well, give me a sec. I will revert it because it's not currently working as it is. Game. Target elevation. And there you go. It's reverted. And now your script should work. So the first thing that I need to do anyway is make it so that when we hit the target, we are actually vertically in the right place. Why are you? Oh, duh. It only appears that way because I also need to remove it here. Pew. Okay, there we go. Shoot to 80. Pew. Oh no. 1.5. Pew. Why are you missing? Oh my goodness. Yeah, so you can see that you could have seen that it wasn't exactly hitting the right spot. Do you need the guidelines or anything for your script to work? So for example, we are working on this archery game for the bot. So from the line right here to the inner line next to the audio, which is right below this spot here, that is 70 meters. And that's 100% of the distance. And right now it's saying that we are at 66.58%, which is 48.04 604 meters. So if you can calculate that, and it's sitting on the ground, and the target is, how tall are you, target? Maybe I should just like move. Hey, you got it on the third shot. Your script got it on the third shot. Okay, I am gonna resize this. How is that gonna work? If I resize you to here so that we can still see chat while I have the debug stuff open, and then I move you down here. I wonder if I could still tell you to be the height. Oh, okay, that's what I'll do. That's what I'll do. So I'll undo all that. I will make the browser source more narrow. And that narrow will be, I don't know, 200 pixels less. What does that look like? Well, that's not helpful. No, you're supposed to be like, don't you update the actual control? I don't know, man. Ooh, Disco's in Unity working on a baseball app. Celia said, is the target defined as a point or a rect? It's a plane, actually. So it is only the inner side of the rectangle that matters, the part that's facing the archer. And so it is a lower point and an upper point. So 2 points that define a line. Or actually, it's a lower point and a height. So even though it looks like it's got depth to it, I'm working in Unity baseball app. I'm Tugasoft. Yeah, I don't. How do I? Does anyone know how to use OBS? Because I sure don't. 1720. How do I tell the OBS browser source to fit to the browser size and not transform, edit transform. Size is 1720 by 1080. Bounding box size. There we go. Okay, so what I need it to be is 1705. Cool. Close you. Change you to 1705. Click OK. And then change you, transform, reset transform. Haha! I think that didn't work. Transform, edit transform, 1705. No bounding box. Wait, that did work. Okay, cool. So now the only overlay that we get is on top of my code instead of over chat. So for those of you that are using chat inside of your own other device and you aren't using the chat box, The shot is pre-calculated. Frame-based, yeah. Wait, sim frame-based or pre-calculated? It's pre-calculated and then turned into positions on frame. I'll show you. Let me just finish sizing this by doing what? Oh, you can already see this on screen. So I'm going to position you first of all. Position X. We'll go to the right, like so. And then width. Slowly increase. Like very slowly increase. I wanted this to increase by 1. Too much. Oh my goodness, just cooperate. This isn't Unity. Tell you that much. All right, we're gonna do this by hand. Add 20 pixels. Add another 10. Cool. Okay. All right, you win. So if I hide, or no, I need to get this first. Are you actually copying? I don't know if it actually copies. Well, I can find out real quick. Pasta? Nope, does not copy. Copy. Pasta. Good. There we go. And now OBS source. Browser source URL. And there we go. Okay, game reset. Okay, so Julius's question is, and is the shot sim frame based or pre-calculated? If frame based, are you sure it calculates the target intersection between frames instead of only on frames? That is a very good thought. Let's look. That is a very, very good thought. So here is launch. Launch. Here's my launch logic. It takes in the frame rate that you want to get all of the positions for. So that as it goes, we can draw it at each point. And what I actually do is I interpolate between each frame. So my CSS animation is make this point show up, and then from time t to time t plus 1, animate it from position A to position B in a linear fashion. And there's small enough time frames that the vertical not being linear should be fine. Disco says, they hacked my Facebook. Who hacked your Facebook? That's no good. Okay, anyway, not anyway. That's really important. Stand-up comedy. I'll just narrow my eyes at that and act like I know what you're talking about. So when we shoot, we're given an initial velocity in terms of strength percentage between 0 and 100%, where the maximum strength is defined in archery settings, right? I forgot that. So maximum strength, come here. Come and see you, beta. Maximum strength is 106.68 meters per second. And for now, that's what we're going to do. Just a solid 0 to 106.68 meters per second. So we split that up. We get that strength and the direction that it's going, an angle to this direction. So 0, positive 90, negative 90 kind of thing. Right, and that's what I'm going to show you as we go through this. So you'll be able to answer that question yourself, I hope. So we have that information. We get the x and y components of the initial velocity. And then we say, how long would it take to get to the target horizontally by taking the distance away that the target is divided by meters per second, which will give us back seconds. So the x component. We use that. And then we also say, how long does it take? That's what I'm doing wrong. How long does it take before it hits the ground? And so that's what all of these calculations are. So that's this. This is actually all determining how long it takes to get to the ground. Okay, Zulius. So like, I'm using the information from the interwebs in order to come up with these numbers, if you couldn't tell. Where even is the archery settings class? Why didn't you stay? Did I actually close you? So I got this from Olympic Values and put it in meters myself because 0 meters, 100, you know, calculating meters and equal, whatever. Doesn't matter. His Ultra Lord, how have you been? My baseball world will be cheating. I purchased Teleric controls and now I'm poor. Well, I hope you get a lot of good use out of them. So one thing that I think I'm doing wrong is how long would it take for the target or for the arrow to reach the target if it was only traveling in the horizontal direction at its velocity? So my question to myself is, hey Figma, I think this works now that I'm thinking about it a little closer as I am starting to open up Figma. I don't know which account my Figma is. Pick one. This is in the way. That's the right one. This one, please. It's okay. I'm just making fun of Imperial units again. I know. Okay. So let me write out the steps real quick. Get the X and Y components of the velocity, calculate time to ground. Actually, calculate time to original height. Oh, wait. Oh my goodness. If it was only traveling horizontally, then determine how long it takes for the projectile to get to the ground. So we get the time to maximum height. Oh, I really want to write this stuff down. You're not going to be able to read my writing, but that's fine. Okay, so now give me a pen. Korewa pen desu. Everything is in the way right now. So hard to write. Move. Move. Give me some space. Careful, soon the Imperial strikes back. It's not for the animation, it's for the making sure that I actually am calculating the arrow's position at time t. That's the thing that I really want to make sure I get right. For the animation, again, like you said, that's fine. It's just when the arrow reaches the target, are we actually calculating the last frame as maybe a half frame when it reaches the target? And I was going to show you that, but I'm also validating all of the calculations that are being performed because I do that. Slightly bigger. Yeah, that works. Okay, so the first thing that we did was we input the draw force and angle. That's gonna say angle when I show you this, even though it doesn't look like angle, but it says angle. It's also like correcting my writing and making it weird. More weird than it already is. Then we convert draw force to velocity. No. Turn off touch. Get X and Y components of velocity. Then we determine how long it takes to get to the target horizontally. In X direction. Then how long to ground. Ground in the Y direction. Okay, so that's this. Let's validate this logic. If anyone is paying attention and can help me out with this, please do. The time it takes to get to the ground is the initial velocity in the Y direction, or the time it takes to get to the maximum height, sorry, is the initial velocity in the Y direction. Oh, what's going to happen when it turns negative? Divided by gravity. So meters per second in the Y divided by meters per second squared. Isn't it something like V naught plus V naught T? Oh yeah, that's what it is. V naught T plus V naught G T squared. What? Plus GT squared? Calculate time to max height. Yeah, we'll just do that. V naught Y, V naught in the Y direction plus AY T. And how do we solve for T here? This looks wrong. Oh my gosh. I just saw a screenshot of a Reddit post. Climate change is really messing up the natural order of things. It's the start of winter, and yet I see species that are meant to be dormant like bees, mosquitoes, and humanoid out and about. Mosquitoes and humanoid? I don't know what that means. Thank you for pointing out the funny article. We're not going to have a discussion about climate change on this channel. Can someone just solve for t in this equation? Just give me the final equation. T equals v naught yg. The maximum height of a projectile. So v naught, that doesn't make sense. T equals v naught of y. This should say over g, right? Over 2g. Use the equation. Height is v naught y over 2g. We calculate the maximum height first? No. I mean, we could calculate directly to time. I don't know what we're going to choose to do. Anyway, directly to time is initial velocity in the y direction over gravity. That's what I have here. Initial velocity in the y direction over gravity. The problem is that if we're shooting downwards, then there will be no maximum height. Shooting downwards. So if we did archery and we shot at -4, 5, whatever, bang, shoot at 100. I am overthinking it. Then it's going to continue going downwards for a really long time. It's... No. So my goal today was to fully read through the launch logic, validate the calculations, make sure that the calculation at each point for my animation is correct. Hello, Xcoding. And then as long as the modeling is correct, then the only issue we have is the animation being drawn on screen correctly. But if I have an issue in my simulation, then it's never going to appear correctly in my animation. Right. Okay, so time to max height. If angle is greater than 0, then, oh my gosh, then it's this calculation. Otherwise, it's just going to be 0. Okay. Could our points be the max? Maybe. Issue in a simulation? I knew it! So we are in the Matrix, absolutely. Okay, so here is taking into consideration if we're shooting downwards. It will be at its maximum height if we are shooting downwards. So the time from its original height to the maximum height is going to be initial velocity in the y direction, provided we are shooting it up, divided by gravity, meters per second squared. And then the time it'll take to get back to its original height will be the start time, which is 0, to the height time, and then back down, which is going to be the exact same amount of time as the height time. And then the time to ground will be how long did it take to do that, plus the square root of 2 times the initial launch elevation divided by gravity. Square root of 2 v naught. No, 2. What is this? This is meters divided by meters per second squared, which just gives us seconds squared, and then we square root that. So I'm going to assume that that formula is correct as well. I remember looking this up. Calculating time to ground with initial velocity and height. Yeah, square root of 2 times height times gravity. Again, that should be divided by gravity. Oh, okay, so time equals square root of 2 times height divided by gravity. If we were just shooting straight down. Ooh, how do you think, how do I think? Well, that's a hard one because most of the time my thinking is passive. I have intuitive intuition, or sorry, introverted intuition is my primary function. That's not what you're asking. Let me get this out of the way. Anyway, should I switch from Visual Basic to PHP, or it isn't that good yet? I can't really comment on PHP too much. I haven't had very much experience with it. I would prefer to use .NET technologies. So if you're already using Visual Basic, why not go to C#? Or why not go to VB.NET? If you're talking about doing web applications. Dukasoft says, I'm not at work. Stop talking about PHP. I mean, it is an honest question and it is worth more consideration than I'm giving it because, again, I'm partial to .NET technologies. It is absolutely possible. Hey, this is the one that I want. It is absolutely possible that you will enjoy programming in PHP more. Oh, yeah, I always forget to consider, are you looking for learning PHP or adding PHP to your skill set in order to get a good job? Then sure. My first thought is always, is this something I'm going to enjoy working in? And right now, I can say absolutely yes to .NET. .NET this, Blazor that, Blazor everywhere, Blazor everything, all the time. Okay, duration of flight. There is no vertical component in the initial velocity because the object is launched horizontally. Not in the second example. Wait, you're showing me 2 examples, and in this one, you're showing me where... Oh, I guess this is white. Good grief. Just make it easier. Oh my gosh. Do one picture, one formula. Starting from here to here, you have these formulas. Time to maximum height. Time to ground is just 2 times time to maximum height. Time when you are, or maximum height and maximum distance, R. And time to maximum distance, which is just going to be time to ground. Then the other one that I want is what I thought this picture was, which is, let's say you're starting at a position at an elevation above ground, and you want to know the time it takes to get from that elevation to maximum height back to that elevation to the ground. Looks like I'm working on baseball. No, archery. Archery. Can you not see my little archer? Okay. So here we go. We can still use this formula for getting from some velocity towards the ground, which was at a given height. And how long does it take to hit the ground? I've already lost that formula. But it was definitely square root of 2h over g. This one. 0 launch angle. An object launched horizontally at height h travels at a range of v0 initial velocity times square root of 2h over g. During a time of flight of t equals square root of 2h over g. But this is launching horizontally. I want launched at an angle. So it would be v0 t minus 1/2 gt squared. And that's hopefully what I have here. Negative h equals v0 t Why are you v0 squared? Minus 1/2 gt squared. Solving for t, we get minus h. Oh, I keep putting the equal sign because we're so used to just putting equals. So then we put h on the other side. Wait, why are you doing that? We're trying to factor out t. So we get minus h divided by t is equal to this. I don't know how to do this. I've completely forgotten how to do this, man. Let's multiply everything on the right by h. Divide everything on the right by h. Yeah, the one that's getting me is this is going to be like t. minus gravity. This is terrible. This is so bad. How do I pull out t from this? You can't. You just can't. Ugh. I can't maths right now. I can't maths while you're watching me. We're going to assume that this formula, time equals 2h over g. So does this mean it doesn't matter? I mean, it has to. The initial velocity in the y direction doesn't matter? You need a cup if you pull out a t. True. This number here is not 0. That's what my issue is. This number here is the initial velocity, but in the negative direction. And we have t. We have t. We want to solve for t though. Anyone? Okay, here's the picture. We've calculated the initial velocity in components x and y. We've calculated the time to the peak, which also means 2 times that time is the time back to its original height. And so at this point, our velocity is negative whatever we calculated for our initial y velocity. And we are at height h. And we're calculating how much time does it take, starting at height h, at a velocity of negative initial velocity, to get to the ground. So y minus y naught is going to be the height, the initial height in this equation. Yeah, so that's the problem though for me. So y minus y naught is going to be the height that we're trying to get to, and then the initial velocity times t minus 1/2 gt squared, and we want to solve for t. I'd say it's greater than 0. So helpful. Oh yeah. An algorithm that gives the locations per time step. No, I already have that part. What I that's not the part that I'm stuck on. I mean, we'll need this. We will need this. So let me copy. That is down here. Get position. Actually, it's not get position. It's get positions. For animation. So yeah, you're 1 step ahead of me because I'm slow. VIP 1-month subscriber or 11-month subscriber. Turbo Zulius. Moderator Automated Realms. Okay. Locations per timestamp for an arrow in flight between its launch and endpoints from a given launch angle and velocity, so that the series of locations can be used to decide scrolling video game. This is what it'll look like. So that's what this is, and I'm pretty sure that's correct. The one that I'm not sure is correct is time to ground, which is time to original height, because this is not taking into consideration my initial velocity. And I don't know if it needs to or not. For calculating the time to ground given an initial y velocity and height. Assume no wind resistance and gravity is 9.8 meters per second squared. I keep wanting to work on my own bot again, but I spend all my time either watching YouTube or playing ESO. Gotta get back into it. I spend all my time doing work. So height plus initial velocity, which you can't do. You can't add meters and meters per second. Unless that's divide. Initial. I got the same issue, but with Twitch and YouTube's. All right, so 1, and I need to see this as a okay. Initialize the y velocity and height, set the gravitational acceleration. Use the following equation to calculate the time to ground. H plus v naught y over g. You can't add meters to meters per second. Zulia says, yeah, but since I got laid off end of last month, my work isn't really occupying my time there very much right now. Definitely understand. Oh my gosh. Oh my goodness. Okay, this is wrong. I don't like this website for it. This one gave me most of my formulas that I was looking for. So free fall is V naught plus GT. And here, if we solve, yeah, but I need height. If you want to calculate the distance traveled by a falling object, you need to write down motion, which is s equals 1/2 GT squared. If the initial displacement and velocity are both 0, is that just a reaction, or is there a message that's not showing up? Sorry, I'm getting messaged by Oh my gosh. Um, um, I'm getting messaged by Sajetti oh, don't mind me. It's just anxiety. Um, this is what it looks like live when I get like for real flustered, like not just overwhelmed by chat, but oh my gosh. What is the JHTTA algorithm? Just hit the target already. Okay. Oh, help. Help. Every engineer gets frustrated. Every engineer understands. Thank you, Equality. This is more of a people thing. My HR office shifted from the Arizona office to Texas. And so the HR point of contact person switched over, and he said he's going to be in Denver next week and wants to know if I want to meet up for coffee. And this is like, everyone else is like, it's just a question that you're asked. Just say yes or no. What's so hard about it? And I have these conversations in my head, and it bothers me when I hear other people say them out loud. So I try not to say this out loud when I get affected by it, because I don't want to hear it. I get affected by it the way that I get affected by it. you know? Anyway, so that pretty much raised my body temperature about 60 degrees in 2 seconds, and now I'm just flustered and don't know if my response. And now he wants to meet over Teams. How many feet is that?
Make your dreams come true.
Exactly. Oh man, I am like sweating and my hands are clammy and it's not good times. So now I said it out loud. These are the things that happen to me whenever someone says, "Do you want to meet? Do you want to do something in real life? Do you want to XYZ?" Oh, now you know. So we're trying to do it's a prop. Oh dear. Anyway, thank you so much for the bits. for the Clayman shock. Yes. Oh dear. Give me a second. I'll be right back. Mentally. I'm going to stand right here while I be right back, but I'll be right back. Yes. Actually, you know what? I will be right back because my water bottle is empty. So I'm going to get some water and then I'll be right back. Can I do the water screen? Do I have a water screen? I don't like that. No, I don't like that anymore. Don't I have a water overlay? I thought I had a water overlay. No idea. We'll go to window swap scene so that you can look out someone's window. Sure. We'll say that I'll return in 30 minutes, even though it'll be like 2 minutes. And my key precursor. Dun dun dun. It's a trap. I'm back. Oh, could you hear me? Yes, it was a hot mic. So I put so bad at this. I pushed the keystroke that I use on Zoom on my work laptop to mute my mic, and that doesn't really work in OBS. Anyway, so hopefully you didn't hear me complaining to my wife. All I was doing was just telling her the situation that happened. She's really, really understanding, and that's why I like to talk with her. But yeah, it was just unexpected. That's all that happened. Hi, Big Gamey. Hope you're doing great. Thank you so much for doing the shout out to Big Gamey. SO. Everything is fine. It's. I don't think, to myself, considering how much this actually affects me, I don't think I'm overreacting, but of course other people would see it as an overreaction, and that's why I don't like sharing it with other people that don't quite understand social anxiety, introversion, etc. Mumbles, crumble cakes. Anyway, let's get a clip from Big Gamey so we can have more fun, pick up where we left off, and clip.
What we'll do is take this section here. Oh, excuse me.
I'm not exactly sure what we just heard, but we heard something. Yeah, I know Dukasoft would understand. But I try not to react outwardly, but I think it's been like a really, really long time since I've had to physically interact with people, so I've gotten out of practice of not reacting to that danger because it really feels like life or death danger kind of thing that I need to plan for. So anyway, Big Gamey, do you know anything about doing your own calculations for in-flight trajectory stuff? I got everything except for I'm questioning this formula for how long it takes an object given an initial velocity, initial y velocity, and height, how long it and gravity and no air resistance, how long it takes that to hit the ground. So there's some formula that's like beginning height minus ending height is equal to the initial velocity times time minus 1/2 gt squared, minus 1/2 times gravity times time squared. And I need to solve this for time. Because I have this, which is going to be my initial height. Height at time t will be 0. Initial velocity we have from this, except it'll be in the negative direction. And g is gravity, yes. And I need to solve for t. And that's what I'm trying to avoid doing, Dukasoft. Like, you can see everything is working the way that it's supposed to. Oh, I'm already archerying. So if I try shooting at a 80 degrees, so, you know, pretty high straight up, and let's say 50 magnitude, which is half of my maximum velocity, it travels in the arc that it should. Here it comes. It's coming back down. Maybe it went too far. Let's try a quarter of that. So right there, it was supposed to stop at 0, at the ground 0. And so I'm pretty sure the calculation to go from initial height, maximum height, back to initial height is correct. It's going from the initial height to the ground given that velocity. The height the arrow was fired at from. Yeah, sure. Which will be ground level 0. So this formula turns into height equals v0 times t minus 1/2 gt squared. I mean, I have tried. I think I've tried. ChatGPT. Like my LLM didn't tell us. My LLM gave us something wrong. My local LLM. How do I calculate the time it takes for an object to reach the ground given an initial height, initial vertical velocity, gravity at 9.8 meters per second squared, and no wind resistance. Okay, so I'm asking ChatGPT, and it's answering very, very, I'll paste the answer that it gives me. There it is, V naught over G. That's all that it was missing. I see what you did there. Okay, so the answer that it gave me is T equals V naught in the y direction over G plus the square root of 2h. This is wrong. 2h over G. So the only thing that I'm missing here is V naught over G. Okay, and then I'll read what you have. Plus. I don't know why I'm putting parentheses. We don't need parentheses. Okay. All it took was BitGamey showing up. That's it. Can't you just say if height is less than or equal to initial height, or hard code the number if the ground will always be at the same height? Yeah, ground will always be at the same height, which is 0. The initial launch height will be variable, and ChatGPT using Unity. The initial launch height will be variable, and the target height is going to be variable when we get to that, but we're not there yet. Oh, .y. Okay, so this is what we have. We have the time that it was already in the air for, plus the time it will take for it to get from its initial launch height to the ground, given its initial launch velocity, except in the negative direction. Over gravity. And this would give us seconds back, plus the square root of 2 times height over gravity, which gives us seconds squared back. Square root that, and we get seconds back. I don't like this at all. But anyway, let's just see what that formula does to our animation. Actually, no, that shouldn't do anything to our animation because this is not used in the animation at all. This tells us whether we hit the ground before we horizontally reach the target. And so the reason that this works is because we're only taking the x component of the velocity, meters divided by meters per second is second, and we're saying how long would it take if we were traveling at a constant speed horizontally at initial velocity of whatever our x component is, how long would it take us to get to the target, regardless of if we're going to hit the ground before we make it to the target. It's just, that's how long it'll take to get to the target. This is how long it'll be in the air for. Time to ground, or we'll call this flight time. This is how long it'll be in flight for. If time to target is less than flight time, we know we didn't hit the target. So that's the very first check. The next check is if we think we hit the target, if we made it far enough to hit the target, then where was the arrow at the time it made it to the target? What was its distance at the time it made it to the target? So time to target in this case should always be greater than or equal to flight time. So I don't know why I'm doing a check here. And actually this has to be, yeah, less than or equal to. So if we hit the target, we know time to target is always going to be less than or equal to the flight time. Oh. I mean, yeah, this is fine, I guess. This is unnecessary, but this is to remove the need for an extra calculation. Pretty much if time to target is equal to flight time, then we know that it's at 0. That's all this is saying. I'll rewrite it that way. So we know that the arrow hit the target exactly at its... Oh, that's even wrong. Anyway, we know that it hit the ground when it reached the target. That's what we know. Something. Then to find out whether we hit the target, whatever the arrow's elevation is at the target, at the time it takes to get to the target horizontally, if that elevation is somewhere between the target's elevation and the target's elevation plus its height, so did it hit anywhere in that vertical distance from where the bottom of the target is to where the top of the target is, yeah, then we know we hit it. I'm going to rewrite this again in a way that's easier for me to read. I don't know if it's easier for you to read, but this shows me the arrow's elevation at target distance is between target elevation and target elevation plus height. That's how I can read that a little easier. So then the next question after we find out whether we hit the target or not is how far away from the middle of the target did we hit? Because that's what's going to determine the score. All right. The possible distance it could have traveled will be the full distance from 0 to flight time, given the initial velocity, and we only care about the x distance. Why do we need that? I don't know why we need that, but we have it. So here we are. This is the initial question that Zulius asked. Zulius, was it? I think it was Zulius. Pretty sure it was Zulius, which is when we are calculating the animation frames, are we calculating the hit point as on a frame or in between frames? Because a lot of times it looks like the arrow goes through the target. So the first thing that I wanted to do was verify that our simulation calculation was correct. Yes, which we did. Right? Right. So now we're sure our calculation is correct. Let's see what it broke. Archly, go, shoot. 240. Pew. Hello, animation? No. Oh, I put at you. At this. Oh, but it didn't stop at the ground again. Why aren't you stopping at the ground? All right, let's try 50. Pew. And finally, let's try 2.5. Okay. So in this case, this is where I think on the idea that hits are calculated from frame to frame. So did arrow intercept target plane? And yeah, that's not what's happening. So what's happening is it is fully simulated position to position on frames. So that's this method here that we're going to jump into. What is our frame rate? Give me the launch result itself. Why do I have the keyword ref here? Are you a struct? Ah, that's why. Okay. So because structs are value-based, I wanted to pass in a reference to the object. So I'm using the ref keyword. How far away is the target? Man. Like this entire thing, since this is not static, it should be using archery settings. So we're going to get rid of target distance in meters. We're going to get rid of initial launch elevation. I'm going to go ahead and allow us to pass in the initial velocity so I don't have to recalculate that. This is initial velocity as the X component, Y component. And then we will do target distance is going to be in place of U. And then initial launch elevation is going to be archery settings dot initial, nope. Where are we getting initial launch elevation from? Oh, it's actually part of the projectile itself. And so what I think I needed to do... Hello, Dragon Spirit Games. Glad to see you come in and say hi. But there's never any obligation for you to come to the stream. I really do appreciate you being here, of course. So don't feel bad if you ever miss my streams. But I am really glad when you do show up and share your energies. But I'm recovering. We're getting better now. Okay. So here's what we are trying to calculate. Zulius asked Automated Realms, the LLM that I'm using, to come up with an algorithm for calculating position over time and giving us timestamps and the position. First, let's read through this logic to make sure it seems correct. We have some hand wavy things that we're going to do. So assume that these are correct. We'll go into them and verify that they are correct. But we are getting the position, and position is going to be a vector 2. So the X and Y positions. I don't feel obligated, just wanted to be here before I go entertain my audience with my obnoxious coughing. Totally okay. I do lurk on your stream whenever you are live. I don't speak very much, as you know. Most of the times I am working. And then if I am building, I'm probably... Like, the times that I start chatting on people's stream is when I'm building our project. Oh yeah, and if you guys don't know Dragon Spirit Games, someone you should definitely check out. Here's... we'll do you have clips yet? I hope you have clips. Because we're going to do a shout out for you. Fancy Pants shout out. Fancy Pants shout out is the one that Dukasoft did. We're going to do a clip shout out. So let's see if we can get your one clip. Dragon Spirit games before I play it, know that he's working on a game called Gaia. It is about his daughter, who's named Gaia, who goes on an adventure. She meets the actual Gaia. They go out and try to save the world. Gods aren't allowed to intervene directly with human stuff, so Gaia is working through Gaia to help clean things up and make the world a better place so that it doesn't just implode on itself in the next however many years. Here we go. Flip.
Don't you know I'm still standing better than I ever did? I look like a true survivor, feeling like a little kid. And I'm still standing after all this time, picking up the pieces of my life without you on my mind. I'm still standing. Yeah.
Absolutely. Elton John and game dev have always been inseparable, says Big Gamey. Absolutely. No, it's a great song. We are not making fun of you at all. I was jamming out with you. I hope you don't feel like we were making fun of you. Not in the least. One of my favorite extracurricular activities is karaoke. But I only do that in private with my wife. But definitely fun times. Also made me sing Tenacious D. I only know that one from Rock Band. Tribute. Okay. Oh, and one thing he wanted to make sure we point out is that the game is accessible too. So it's not just for one audience, it's for all audiences, people with disabilities, people with handicaps, that don't have full access to, let's say, vision, for example. They will still be able to play the game too. And have as a good experience as anyone with full vision. Ooh, deaf, physically disabled, and of course, everyone without disabilities. Yeah, that's awesome. So cool. Super duper cool. This game kind of is, so if you have a screen reader, then you will hear whatever's in chat. So you redeem archery and it says, you. Why does it say you? It's your turn to make your move. To shoot, type shoot, followed by you angle and draw force. For example, exclamation point shoot. 3 chances to hit the target, close to the vertical center. So again, I'm going to shoot super high. Hi, you. I'm Dukasoft. I'm going to shoot super high into the air at a low magnitude just to see if it lands on the ground. That was supposed to be a low magnitude, dude. It does not land on the ground. Do you shoot sheep instead of arrows? Should it be you? And then it gives me information. I need to make sure that this thing always includes like how far over you were or whatever else. Yeah, it's definitely not stopping at the ground, and it needs to stop at the ground. But let's do a low angle, high velocity. Hopefully we make it to the target and hit it. Nope. Congratulations, you did your best effort, but it looks like you suck at this game. Thanks, Automated Realms. I need to see what it looks like when we actually hit the target. So this one, maybe. Okay, all right. Wait, what? Wait.
I got a bad feeling about this.
You managed to hit the target with a score of 100 points on your first try. No. And why is all of this red? Why is my PowerShell suddenly red? Distance. Distance from center, negative 0.001 meters. And so 1 over this, or 1 minus, you know what I'm trying to say? We get the distance from the edge of the target to the center, this divided by that, times 100. But this is more like the distance from the bottom edge according to the picture. It looks like I am negative 0.001 units away from the bottom of the target. And we know that we're calculating duh. Sure. Yes, absolutely. So again, I need to, man, you just reminded me. I really, really want to be able to have, not want to be able to have, I want to make an alias commands table so that I don't have to recreate the entire command when I just want to create an alias for the command. Flag is an upgrade. So here's shoot. This is actually the thing that I want. So let's go pew. $1, $2, 0, 0, 0, 1, 0, pasta, 10, true, today. Okay, and if we say automated realms, refresh commands, then now I should be able to pew at the exact same thing that I just did, 260. Oh. Wait, did I miss a thing? I'm pretty sure I missed a thing. Game page. Shoot, pew. I'll reload. There it goes. Pew pew. Your wish has been granted. Should it be poo? You shoot poo instead of arrows, and then you do poo flag, and then the flags are the upgrades. Anyway, we can definitely build on it. But first, I want to make sure that the animation is modeled correctly. Let's do that first. So the thing that's happening is, how did that even work when this thing is giving me errors? Like, it hot reloaded even though I had errors in my projectile class. How did it hot reload still? Anyway, we should be hot reloaded now. Looks hot to me. Okay, archery. Go again. Pew. At, whoa, super far away. 380. Too high. 370. Oh, 365. And there it goes. It went straight through the target. We saw it go through the target visually, even though it probably didn't. And see these negative numbers here? These negative numbers should not exist. Okay, so here's what PU. You can also play archery while I'm still trying to do this, by the way. You don't have to. Let's not be negative. I mean, don't be toxically positive either, but also. Arrow elevation at target distance is 0.75 meters. Target elevation is 0 meters through 0.71 meters. So, again, the drawing on the screen is what seems to be wrong. Let me tell you what yours is so that you have a little bit of a better chance. This is what it should tell you. You were 1.75 meters above your target. It is very spammy. It's got way too many words. So maybe we'll just use stock messages. I agree with you. Stream ideas. Archery messages are too long, a bit spammy. Yeah, maybe we'll just do result and then distance above target. You have 2 more shots, by the way, Bikini. Okay. So position time, why are we getting negative? Time to ground is getting passed in, and time to ground is whoa, so close. Except visually so close, but the actual closeness was 0.3 meters above. Yeah, it went through the target, and that's what I'm saying. That's what I want to fix. So right now the animation makes it look like you go through, even though, according to this, at the target, your arrow was supposed to be at 1.4 meters, and the top of the target was at 0.76 meters. We're validating stuff. Light time. Flight time is supposed to be the time it takes to get from your launch height to the ground. That's it. Why, oh why? You know what? If yeah, I think that, Zulius. I think that. And it's because scaling it is hard. So right now we're using 100% horizontally to be 70 meters. That's really easy to calculate. We do 70 meters over 100% to get meter per percent, or the opposite to get percent per meter. However, we're going to display it. But anyway, that one works fine. So the horizontal traveling is good. The vertical is not based off of ground level is 0, top of the play space is 100. But maybe that's what I should do. But I still need to verify that it's calculating each position correctly. And I'm still thinking that this is what's incorrect. Calculating the total flight time. This is free fall. We want projectile motion. Okay. To get back to the original height is going to be V naught, vertical component of the initial velocity. So V naught Y over G. T equals V naught Y over G times 2 to get back to its original height. Then we add the time it takes to get from its original height to the ground at initial velocity in the opposite direction. Which is V naught Y over G plus square root of 2H over G, which we just looked up. Maybe gravity is positive. Gravity is negative, which is why we want negative velocity. Yeah, certainly. Ew, no, just give me this. Copy. Pasta. There. Find the time of flight and impact velocity of a projectile that lands at a different height from that of launch. I want this. Hello, Crapteen. Great name. Hopefully I didn't mispronounce it. How are you feeling? How are you doing? I am trying to do some projectile motion simulation in C#, like pure C#, raw C# only. Where my initial launch height is different than my ending height at ground level. And this one says V squared not Y over 2G. Guys, do the opposite of this. Yeah, this is exactly what I'm trying to simulate. We have a projectile that is being launched relative to the horizontal plane at 45 degrees with an initial velocity of 30 meters per second, and it's actually ending further down than its initial height. So it should always end like this list of stuff. This list of positions should always end at 0 or above 0 if it actually hits the target. But here we can see that it's going negative, which means that I'm calculating the total flight time incorrectly. So given this formula, final y equals, dude, stop selecting the whole thing. Final y equals initial y plus initial velocity in the y direction times t minus 1/2 gt squared. We should be able to do this. The problem is solving for t in this equation. I still don't know how to solve for t in this equation. I see Blazor, how is it? Tried it in .NET 6 and had to learn JavaScript instead, but heard they made nice changes in .NET 8. I absolutely love Blazor. This is our main project that we've been doing on stream. You can see it on YouTube's. I have it in a playlist. I beat you to it. So we did a financial management tracking system, which is an application that I was just using to do a real world example of, you're making a project for a customer. And we were supposed to be using all of the programming principles, doing test-driven development, design, everything from design, concept, design, implementation. And so this was part of the design. So we came up with, this is our landing page. We have some input forms, and we coded the entire application functionally, not beautifully yet, but functionally, and came up with a really good application. So then I'm like, all right, now that it's functionally working the way that we want it to, let's go through what it would be like to have an existing application that you want to do a UI facelift on. And so we started sketching out some ideas for how to improve the UI. And so that's what this board is. This board is for functionality improvements, for making the app work better. And so that's what we should be doing right now. But right now, instead, I'm playing with the StreamBot, which I made in Blazor as well, because I like to make everything in Blazor. Gorsh, let's put you there. And so the part of the bot that I'm currently working on is this archery game here that you can see at the bottom. So this is me spawned, and then I'm shooting at a target somewhere way over there. And that looks like it's all the way across. So I'm going to shoot at full force. I'm going to shoot at full force, and that went over. So I'm going to shoot at a little less force. That still went over. And I'm going to shoot at even less force. And I hit it. But right now what's happening is you can see that my arrow's trajectory is falling through the ground. And then also the animation is not actually lining up vertically. Like, it's lining up horizontally just fine, but it's not lining up vertically. And so that part I can fix. You need a game where you compare it to, as you're falling, you have 3 chances to shoot a target. That would be crazy. Oh man. But now we have 3 commands to actually launch the arrow. So we have pew, we have shoot, and we have shoot. Oops. The message on pew should actually say exclamation point pew. Because if you're using pew, that means you want to see information about pew, not shoot. What kind of lame pew? Pewt. See, and again, we could just add pewt if I had my other table set up already. Automated realms, refresh, commands. Do it. Thank you. Okay, but we're really close. This is the one formula that I need to get fixed. We have the formula on screen. I need to codify it. Codify it? Codifularify it. We need to solve this for t. Using the quadratic equation. We get 2 values in the quadratic formula. I'm sorry, but I'm not able to solve mathematical equations. However, I can provide a link to helpful resources. Did you steal that from... Oh, who posted that just now? Who just posted Wolfram? Thindle. Did you steal that from Thindle? Fine, projectile path given. We don't care about mass. Okay, anyway, we have a video from Dukesoft. You gave us this before. I mean, you showed us this before. Do they give us the math for that? Or were you just showing us balloons and arrows? I don't think they give us the math for this. Okay, so try solve for t with the formula. Yeah, I've just completely forgotten how to do the quadratic equation stuff. Okay. H final equals h plus v naught y t minus gt squared. Will it do this? We'll just do v naught because it's treating, well, maybe it's treating v naught y as one symbol. I don't know. T equals gt squared plus h minus h naught over v naught, and v naught is not 0. Should my stream be the highlight of anybody's day? I've bumped it to tomorrow. Oh, Big Amy is telling us that his stream is moved to tomorrow, not today. Now you can sub, follow, like, everything, all the positive things, all the good things, to teach me a lesson. That we are not going to abandon you just because you have a real life and you're choosing to stream on the days that you choose to stream on. You are allowed to stream whenever you happen to stream me, and I sport you. We're solving the projectile motion, except that instead of final height being above where you shot from, it's below where you shot from. So it should be this exact formula: y equals y naught plus v naught y t 1/2 gt squared. And is that what I put in here? Y equals y naught minus plus v naught t minus 1/2 gt squared. Oh. Y equals y naught plus v naught t minus 1/2 gt squared. Okay, don't play that one. What am I even looking at? Time equals y minus y naught over v naught when g is 0. Okay, so there are 3 cases. The first case is when g is not 0. And I don't exactly know. So Wolfram is not helping me. It's just making me more confused. I spend most of my days saying why not. Oh man. I'm like, y equals y. Yeah, exactly. Why? No phone. I spent this entire time trying to think this. Why is this hard? Like, how exactly do you apply the quadratic formula and get these values? Is what? This? Or this website? I'll give you the website. One or the other. I mean, we're ending soon, but you know what? C# math library for calculating project. What is it called? Projectile motion. Why is everyone assuming starting and ending positions are the same? And that we won't ever shoot downwards? I watched The Exorcist recently. That had projectile motion. Right side on chat window. What do you mean right side? Because I'm in Chrome. I didn't know I needed to open this in Edge. Y equals y naught plus v naught y minus g 1/2 gt squared. But again, what about factoring in starting height and ending height? Depending on the values of y, y naught, v naught, y, and g. Okay, I could try to use this. This sounds like it's giving us everything with starting and ending heights. I'll look at this on my own time, figure it out, because I'm still reeling. I thought it has MSN Messenger. Why does Chrome have no Bing chat? Chrome does have Bing chat, but it doesn't have whatever this is called. Copilot. Copilot. Bing chat. Okay. Anyway, that's it. I'm gonna recover. We're gonna head over to Dragon Spirit Games. Dragon Spirit Games. I promise I will have the math figured out by next stream. And what we're going to work on in the next stream is the actual animation. So we're going to figure out how to properly scale the Y positions of the arrow. We'll probably need to first create a new arrow sprite, because right now the arrow is a div that is just a rectangle, and then a thank you for posting it in Discord. I'll look at it. And then a before and after for the quack and after for the arrowhead and the feathers. So we'll create a new sprite for that, so that when we animate it, we know that we're animating the left edge of the arrow, even though it's going to be the center of the arrow that's going to travel, and then it's just going to rotate around that center. It is over 9,000. So, yes. Thank you. So we're going to set up a raid for Dragon Spirit Games. Be aware that his channel is not set for mature audiences. So if you are expecting a mature audiences channel, that's not his channel. That's terrible. I will be lurking in his stream, lurking in Finite streams, Setalix, Code Red Games, Irish John when he starts streaming. I'll be everywhere, but I will also be working on my day job work. It's okay, I'm not mature. I hope you guys enjoy the rest of your day. I'll do my best to enjoy the rest of mine. Here's some good music.
Ha! Got him!
Got him. Okay, that's it for me for now. Like Dukasoft posted, I will be posting a recording of this video to YouTube no sooner than 24 hours after I end the stream. Feel free to join our Discord if you want. No pressure. It's a pretty quiet Discord. Not that much activity, but a lot of really cool people are there. So if you do ask a question, you will be acknowledged. You will get an answer. Yeah. I thought my wife was joking when she said she'd leave me if I didn't stop singing I'm a Believer. Then I saw her face.